In 1843, a single star exploded with the energy of a supernova. It should have died. It didn't. Tonight, that star is still out there, 8,000 light years away, glowing in the southern sky like an open wound that refuses to heal. Its name is Eta Carinae, and by every rule we understand, it should not exist. For a few short years in the 19th century, this distant object became the second brightest star in the entire night sky. Sailors used it to navigate. It outshone almost everything around it. Then it dimmed, slowly fading from view until the naked eye could no longer find it. Astronomers assumed they had witnessed a death. They were wrong. What they had actually seen was something far stranger. Eta Carinae had blown off a mass of material equal to 10 of our suns in a single violent convulsion and survived the blast. We call it the Great Eruption. We still cannot fully explain how the star lived through it. To understand the dread here, you have to understand the scale. Eta Carinae is not a star like ours. It is a monster, at least 100 times the mass of the sun, and millions of times brighter. It burns so hot and so fast that it is tearing itself apart from the inside, shedding its own outer layers into space. Stars this massive are rare. They are also doomed. They live fast and they end in catastrophe. But this one is taking its time, and it is hiding something. When the Hubble Space Telescope turned its eye toward Eta Carinae, it revealed a haunting structure. Two enormous lobes of gas and dust, ballooning outward from a central point, joined at the waist like a cosmic hourglass. We named it the Homunculus Nebula, Latin for little man, because in early blurred images it almost resembled a human figure. Those two glowing lobes are the debris of the 1843 eruption, still racing outward at over 1,000,000 miles per hour. The whole structure is now wider than our entire solar system, and buried inside the dust, where our telescopes struggle to see, something is still burning. For a long time we thought Eta Carinae was a single dying giant. Then the truth got darker. It is not one star. It is two. A second massive star orbits the first on a long, looping path, swinging close every 5.5 years. When they pass, their stellar winds, torrents of gas blasting off each star, slam into each other at speeds that defy imagination, heating the collision zone to millions of degrees and flooding space with X-rays. Then, every 5.5 years, the X-rays suddenly vanish. The system goes quiet. For weeks, something switches off. Astronomers have watched this happen again and again, and the precise mechanics of that silence are still being argued over. It is as if the two giants hold their breath, dive into each other's shadow, and then re-emerge. Each time they pass, the dance grows more violent, and every pass brings the larger star closer to its inevitable end. Here is what keeps astronomers awake. Eta Carinae is a prime candidate to become a supernova, or something even more extreme, a hypernova, one of the most energetic events in the universe. It may have already happened. Because of the distance, the light from such an explosion would take roughly 8,000 years to reach us. The star you see tonight is showing you the past. The real Eta Carinae, the one that exists right now, could already be gone. Its final scream still crawling across the dark toward Earth. Not yet arrived. We are watching a ghost and calling it a star. When it does die, the show will be unlike anything in recorded history. Some models suggest it could briefly become visible in daylight, casting shadows at night, lingering in the sky for months. It would be the closest, most spectacular stellar death our species has ever witnessed with our own eyes. And there is a question underneath all of this that no one likes to ask out loud. A supernova this close releases a flood of radiation and high-energy particles. Eta Carinae is far enough away that most scientists believe Earth would be safe, protected by distance and by the orientation of the blast. But there is a catch. Stars like this, when they collapse, can fire off a gamma-ray burst, a beam of annihilating energy focused into a narrow jet. If such a beam happened to be aimed at us, the distance might not matter as much as we would like. The current measurements suggest its poles are not pointed our way. Suggest. Across 8,000 light-years, through dust we cannot fully pierce, around a star that has already lied to us once about its own death. The Great Eruption taught us an uncomfortable lesson. We thought we knew what a dying star looked like. We thought a blast that bright meant the end. Eta Carinae proved that our understanding had a hole in it. that a star can detonate, hurl away 10 sons of matter, and simply carry on burning in the wreckage. If we were wrong about that, what else are we wrong about? What is happening right now 8,000 years deep in that glowing hourglass that we will not learn about until the light finally crosses the gulf and reaches a sky none of us may live to see? The monster is still out there. It has survived once already. And somewhere in the dark between the stars, its next act may already be over, waiting only for the moment its light finds us. So when you look toward the southern constellation of Carina, remember, you are not seeing a star. You are seeing a message sent 8,000 years ago from something that may no longer be alive. And the rest of that message has not arrived yet. What will it say when it does?